right, so quiz tomorrow is 7 questions. We're gonna kind of skim through the review a little bit. For a question like number 1, it says evaluate the definite integral by the limit definition. You don't have to do the limit definition on the quiz. So you can just evaluate your integral using the antiderivative. So just basic integration. So here, when we evaluate the integral, we would first want to take the antiderivative. So we get 3x squared over 2 plus 4x. And then this is from 0 to 2. What would I plug in first? 2. Awesome. So when I plug in 2, we get 3 times 2 squared over 2 plus 4 times 2. And then minus, we'd plug in 0 next. So it would be 3 halves times 0 squared plus 4 times 0. So this would just end up being 0. So we want to figure out the math between the left part here when we plug in 2. So 2 squared would be 4 times 3 is 12. 12 divided by 2 is 6. So we have 6 plus 8. 6 plus 8 would be 14. So hopefully when you did the limit definition, you ended up with 14. But you won't have any where you have to use the limit and your summation rules. It's just take the antiderivative. For number 2, it says sketch the region corresponding to the given definite integral, then evaluate each integral using a geometric formula. You can evaluate this using your definite integral rule, so take the antiderivative from -1 to 3, or if you want to graph it and then find the area under your shape, you could do it that way too. So you will have to find the area using a geometric formula, but it'll give you the graph.
And you find the height by solving it the way that we did the last problem, right?
So if it was like a question like this where it gave you the picture, you could just look at it and see what's your height, what's your width.
So we don't have to find.
All right, let's do number 3. So 3 gives us f of x and g of x and asks us to evaluate. So here I can split this up. I can say the integral from -1 to 6 of f of x dx minus 1/3 times the integral from -1 to 6 of g of x dx. So our integral from -1 to 6 of f of x, it tells us is -5. So this would be -5. Minus 1/3 times our integral for g of x, which g of x says that it's -11, so this would be -11. And then from here, we just have to simplify. So we get -5, this turns into plus 11 over 3. We would need a common denominator, so I could make this -15 over 3. So when we add these together, you should get -4 over 3. B is pretty similar. What would C be? We're taking the integral from -1 to -1. Yes, 0. Awesome. You can move the 3 out front. If you wanted to do it this way, the integral from -1 to -1 of g of x would be 0, and 0 times 3 would just be 0. So we get 0. Let's say, I'm going to make a D question here. Let's say it asks us for the integral from 6 to -1 of g of x. What would our answer be here? It would be positive 11. Awesome. It would change the sign of our answer here. So this would be positive 11. If it flips the integral, it flips the sign of the number. Because it's the same number. So make sure you look back at your rules for these, because these are just properties of our integrals. I'm going to do one more here. let's say we were given, so we're going to use this one again from -1 to 6 of g of x, but let's say we were also given from 6 to 8 of g of x is equal to -3. And let's say for question E, it asks us for the integral from -1 to 8 of g of x. What would our answer be here? So we could split up our question that's being asked into -1 to 6 of g of x plus the integral from 6 to 8 of g of x. So we know that -1 to 6 would be -11, and then 6 to 8 would be -3. So our answer here would be -14. All right, we're going to look at 4. 4, if it gives you the graph here, you can find your area. We can find the area of the triangle just by using our area formula, so using our geometric formula. I'm going to solve this algebraically. So let's say it didn't give us the picture, and it just asked us for the integral from -4 to 4 of 4 minus the absolute value of x. So let's say that this was the question, and it had no picture. And we had to find the integral. So there's a couple different ways that we can do this. I'm going to split it up to make it a little bit easier for us to see. So I'm going to split it up into two integrals from -4 to 4 of 4 minus dx minus the integral from -4 to 4 of the absolute value of x dx. So the first part here, we can evaluate using our integration rules. We can take the antiderivative. Let's do that first, and then we'll look at our absolute value one. So when I take the antiderivative here, I would get 4x from -4 to 4. What would I have to plug in first? I'd plug in 4, so we get 16 minus, when we plug in -4, we would get -16. So this turns into 16 plus 16, we'd get 32. So 32 minus our integral from -4 to 4 of the absolute value. When we have an absolute value, we can't just take the antiderivative. We have to use our rules here, where we have to set whatever's inside of our absolute value equal to 0. And then we have to split it up. So I'd set whatever's inside the absolute value equal to 0. So we just get x is equal to 0. So we're going to split up that absolute value of x into two pieces. We have x when x is less than 0, and x when x is greater than 0. But if I plugged in a number that's less than 0, it changes the sign. So this part gets a different sign. So half or part of it, one piece of it's going to change the sign, the other piece is going to stay the same. So if I plugged in, let's say like -1, something less than 0, the absolute value makes it change the sign. So since our sign changes in the first piece here, we just change the sign of our function here. So now I'm going to split this up. With our absolute value ones, we split it up. Since we said x is equal to 0, that's our value. That sets the inside of our absolute value equal to 0. We're going to split it up at that point. So I have from -4 to 0 of -x plus from 0 to +4 of x dx. And this is all still minus, because I had that minus in the beginning. All right, so let's take our integration from here. We're going to do one piece at a time. So starting with the first one, when I take my antiderivative, I'd add 1 to the exponent, so I get x squared. Yes. So we get negative x squared over 2 from negative 4 to 0. What would we plug in first here? 0. So we get negative 0 squared over 2, which would just be 0, minus, when we plug in negative 4, we would get negative 4 squared over 2. So negative 4 squared would be 16. The negative out front makes it negative 16 over 2. So it would be negative 8. Then we have another negative there, so that makes it a positive. So this would be positive 8. Because this was just 0. Then when we do the second half here, when we take the antiderivative, we get x squared over 2 from 0 to 4. What would we plug in first here? 4. So we get 4 squared over 2 minus, when we plug in 0, that would be 0 squared over 2. So this is just 0. So 4 squared would be 16 over 2, which would be 8. So we end up with 8 plus 8. So this would be 16. So then I still had 32 from that first part. So 32 minus 16 would be what? 16. Awesome. So our answer would be 16. If we took the area of our triangle here using the base times the height, our base would be 8. Our height is 4, so our area of a triangle is 1/2 base times height, so 1/2 8 times 4. We also get 16. But you will have an absolute value question, one that looks similar to this that does not give you the picture. So that's why I wanted to work it out the long way. All right, for number 5, let's just do A. So from 0 to 2, from here to here, we're finding our area. So we have to use our geometric formulas. We're using this shape here and this shape here. Bless you. I don't really have a formula for that first shape under the x-axis, but I can cut it into shapes that I do know the formula for. I can shape this into a rectangle and a triangle. And then above my x-axis here, I also have another triangle. So for our rectangle, or it's actually a square here, our formula would be base times height. So our base is 1 and our height is 1. So 1 times 1 would just be 1. So our area here, because it's under the x-axis, would be -1. Next, we can do our triangle here. So our triangle has a base of 1/2. Or if you wanted to call it 0.5, you could do it that way too. Either way. And then a height of 1. So our formula for our area of a triangle would be 1/2 base times height. I actually like it as 1/2 better. So 1/2 base times height would be 1/2 times 1/2 times 1. So this would be 1/4. Because it's under the x-axis, it would be negative, so -1/4. And then we also have our triangle up here. So this one also has a base of 1/2 and a height of 1. So our area for this triangle would be 1/2 base times height, so 1/2 times 1, which would be 1/4. Since this one's above the x-axis, it's positive 1/4. So when we add these together, Negative 1/4 and positive 1/4 would just cancel, so we get -1. Any questions there? One other formula that you have to know is the area of a circle. What's the area of a circle? Pi r squared. So make sure you know the area of a circle, pi r squared. You might be given a semicircle, so half of that would be pi r squared over 2. Any other questions here? Do you want to C, B, or C? Or you feel okay with this? All right, let's look at 6. We're going to do the second one for 6. So before we evaluate our integral, you have to simplify. Before we take our antiderivative, you have to simplify this. We don't have any rules when we are dividing here. We got to simplify it into one term. So here, I can change this to be u over u to the 1/2 power minus 2 over u to the 1/2 power. So I'm splitting it up into my two terms here. I want to simplify my fraction since I have a u on top and the u on the bottom. If I'm dividing, what would I do to the exponents? Subtract them. So my exponent of the u on top is just 1. So I have 1 minus 1/2 would just be 1/2. So this is the integral from 1 to 4 of u to the 1/2 power minus, here we could move our u to the top. So 2 times u to the negative 1/2 power du. Now that they're both individual terms, we don't have any fractions happening here, I can take my antiderivative. So when we integrate, we add 1 to the exponent, so this would be u to the 3/2 power, and divide, times 2/3, minus, when we add 1 here, we get u to the 1/2 power, divide it by 1/2. Can't have a fraction and a fraction. When we simplify this, this would be 4. You could keep, change, flip. Yep. And then we're taking the integral from 1 to 4. What would we plug in first? 4. Awesome. So we have 2/3 times 4 to the 3/2 power minus 4 times 4 to the 1/2 power. And then minus, we'd plug in 1. So 2/3 times 1 to the 3/2 power minus 4 times 1 to the 1/2 power. So from here, just be careful with the math. 4 to the 3/2 power is like saying the square root of 4 cubed. The denominator is your index of the radical. So this is just the square root of 4 cubed. The square root of 4 would be 2. 2 cubed would be 8. So we get 2/3 times 8 minus 4 times 4 to the 1/2 power. This is like saying the square root of 4. Square root of 4 is 2, so 4 times 2, well, this would be 2. Then we'll simplify here. So we get 16 over 3 minus 8. If you want to combine these together, give them a common denominator, you can here. I'm going to simplify the blue, so the part on the right, and see if I can simplify some more. Or get some more like terms with common denominators. So here, 1 to the 3/2 power would just be 1, so this is 2/3. And then minus 4 times 1 to the 1/2 power is just 4. So this would be minus 2/3 minus 4. Be super, super careful with the signs. I'm going to distribute here, but if you want to combine these together, just get one number. You can do it that way too. So I'm going to say minus 2/3 plus 4. From here, I'm going to add my terms with the common denominator. So 16/3 minus 2/3 would be 14/3. And then -8 plus 4 would be -4. Now I need to find a common denominator. So I'm going to multiply the top and the bottom here by 3. So make it 12/3. So 14 minus 12 would be 2/3. There was one type of question that's going to be on the quiz. It's not on the review, so I want to practice those with you. It is finding the average value and finding C. So let's say it asks for the average value of f of x, which is equal to, we'll call it x minus x squared. We'll keep it simple. On the interval from -1 to 2. What would we do to find the average value? So for our average value, we have a formula, which is the integral from -1 to 2, or from a to b. I'll call it a to b since I'm going to write the formula here, of f of x dx. What do we multiply it by to find the average value? Anybody remember? 1 over what? B minus A. Does this look familiar now? A little bit, maybe. Go back and look at the notes. So this is our formula. If it asks for the average value, we're finding the antiderivative. We're taking our integral. We're just multiplying it by 1 over B minus A. This is our A, and this is our B. So here we have 1 over 2 minus -1 times the integral from -1 to 2 of x minus x squared dx. So this would be 1/3 times the integral from -1 to 2. We can take our antiderivative now, so we can evaluate our integral. This would be x squared times 1/2, or I'm sorry, divided by 2, minus x cubed divided by 3, from -1 to 2. So we're going to evaluate our integral and then just multiply it by the 1/3 at the end. So when I plug in 2 first, we get 2 squared over 2 minus 2 cubed over 3. And then minus, we're going to plug in -1 next, so -1 squared over 2 minus -1 cubed over 3. So 2 squared would be 4, divided by 2 is 2, minus 8 over 3, minus, here we would get 1/2. -1 cubed would turn to, or stay -1, so this would make it a plus 1 over 3. I'm going to add inside my parentheses here, so I'm going to combine these together. So this would be 6 over 3 when we have a common denominator, so we get -2 over 3. Minus, when I add these two together, I need to change both of them, so this would be 3 over 6. And this one would be 2 over 6. So when we add them together, we get 5 over 6. I still need a common denominator here, so I can change this to be negative 4 over 6. So negative 4 minus 5 would be negative 9 over 6, which simplifies to negative 3/2 times that 1/3 in the beginning. Don't forget, when you're finding the average value, you got to multiply it by b minus a. So we have to multiply it by the 1/3. So when I multiply it, I get negative 1/2. This is my average value. So this is f of c. Let's say we had another question that said find c. What would we do to find c? For c, we just have to set our function equal to the average value. So we get x minus x squared equals negative 1/2. How would we solve this? I gotta move the negative 1/2 to the other side, so I'm gonna put it in standard form, so negative x squared plus x plus 1/2. I was really hoping that I'd get lucky and the numbers that I just made up would factor, but it doesn't always work that way. Here, because I don't love fractions, I'm going to multiply everything by 2 just to get rid of the fractions. So everything is going to get multiplied by 2, so that gets a negative 2x squared plus 2x plus 1 equals 0. If it doesn't factor, what can we do? The ABC thing, what's that called? Quadratic formula. So we could use our quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. So negative 2 plus or minus the square root of 4 minus 4 times negative 2 times 1 over 2 times a would be negative 4. Negative 2 plus or minus the square root of this would be 4 plus 8. So 12 over negative 4. Then we can simplify here. Negative 2 plus or minus, this would be 2 square root 3 over negative 4. And simplify a little bit more, divide all of our whole numbers by 2, or if you want to divide them by negative 2, either way, doesn't matter. This would be negative 1 plus or minus square root 3 over 2. And then we would just have to make sure which one's in our interval. Yes, negative 2 on the bottom. So if this factors and you get 2 answers, double check the interval. Make sure you're giving me a value for C that is in the interval. This one I made the numbers up, so they probably, neither one is in the interval, I don't think. Actually, the plus one might be. So I think that this one should be negative 1 plus square root 3 over negative 2. I think. We could plug it into the calculator to see for sure, but just check. your answer has to be in the interval. It has to be in between A and B. So this would be like 2 questions in one. We'd have to find the average value. Then you set your function. We would set f of x equal to the average value. And solve for x, which is technically just your c. And then make sure it's in the interval.